Welcome, everyone. Let's get started on one of the most critical topics in enterprise AI today, guardrails. As we deploy large language models into production, ensuring their safety, compliance, and professionalism is paramount. Today, I'll be teaching you how integrated safety features keep your model outputs secure. Let's kick things off by defining exactly what we mean by AI guardrails. When we talk about guardrails in the context of large language models, we are essentially discussing the safety nets of our enterprise AI ecosystem. Imagine deploying a brilliant customer service bot, only for it to be manipulated into generating offensive or harmful content. That is a scenario no business wants to face. Guardrails, and specifically Snowflake's Cortex Guard, act as an integrated safety feature designed to intercept and evaluate model responses before they ever reach your end user. Under the hood, this safety layer is powered by specialized models like Meta's Llama Guard 3. This means that as your primary LLM generates a response, Cortex Guard acts as a vigilant referee, ensuring that the output strictly adheres to professional safety standards and actively filters out anything associated with hate, self-harm, or violent crimes. Looking at the flowchart on your screen, you can visualize the fundamental architecture of a guarded AI request. It starts on the left when a user submits a prompt. The primary LLM processes this and generates a raw output. But notice the crucial step in the middle, the Cortex Guard evaluation node. Instead of sending the raw text directly back to the user, the flow is routed through our safety checkpoint. If the content is deemed safe by the Llama Guard 3 model, it proceeds smoothly along the top path to the user. However, if the text triggers any safety violations, it takes the bottom path, intercepting the harmful text and replacing it with a filtered, professional response. It's a simple yet incredibly effective pipeline. Now that we know what guardrails are, we must ask, why are they absolutely essential? The primary driver here is brand protection. Generative AI is incredibly powerful, but it is also unpredictable. Without a safety net, an LLM could hallucinate or be tricked into generating offensive content, resulting in a public relations disaster. Furthermore, enterprises operate under strict regulatory and compliance frameworks. You cannot afford to have a model generating toxic or non-compliant text. Guardrails mitigate these severe risks, particularly against malicious actors who use prompt injection techniques to break the rules you've set for your AI. By implementing automated moderation, you ensure user trust. Your customers and employees will feel confident interacting with your systems, knowing that the outputs will always remain professional and safe, without requiring an army of human moderators. This block diagram clearly contrasts the two worlds of AI deployment. On the top, we see the severe risks of an unfiltered LLM, brand damage, compliance violations, and the generation of harmful content. These are business-critical threats. On the bottom, we see the paradigm shift introduced by Cortex Guardrails. By deploying these integrated safety features, those severe risks are neutralized and converted into highly positive outcomes. You achieve brand trust, automated compliance, and guaranteed professional interactions. It visually reinforces that guardrails are not just a technical feature, they're a fundamental business requirement for enterprise AI. Let's transition into the how. How do we actually implement this, and how does it function mechanically in the Snowflake environment? Turning this on is elegantly simple. When you call the AI complete function, you pass a specific configuration object where you enable guardrails. But the magic happens in the execution phase. Guardrails perform post-generation evaluation. This means the primary LLM does its job and creates a response. Before that response is finalized, Snowflake passes that generated text to a secondary model Meta's Llama Guard 3. This secondary model acts solely as a classifier. It reads the text, checks it against its safety taxonomy, and makes a binary safe or unsafe decision. If it flags the content as unsafe, the system seamlessly intercepts the payload, discards the dangerous text, and swaps it out for a clean, customizable fallback message. I love sequence diagrams because they show the exact chronological flow of operations. Let's trace it together. Your application, on the far left, sends the user prompt to the AI complete function, making sure to flag that guardrails are enabled. The AI function does the heavy lifting to generate the raw output. Then, you see the internal handoff. The AI function passes that raw text over to the Llama Guard 3 participant. Llama Guard 3 analyzes it and returns its verdict. Finally, the AI complete function resolves the request, sending your application either the perfectly safe generated text or the protective fallback string. All of this happens in milliseconds. Understanding when to use guardrails is just as important as knowing how they work. The rule of thumb is, if you cannot control the input, you must control the output. Therefore, customer-facing chatbots are the most critical use case. If you have a bot exposed to the public internet, guardrails are absolutely mandatory to prevent users from coaxing the bot into saying something offensive. Secondly, consider retrieval augmented generation, or RAG, applications. Even if your source documents are clean, the LLM synthesis of that data can sometimes take unpredictable turns. Guardrails are also non-negotiable in regulated industries like finance and healthcare, where strict communication standards are legally enforced. Finally, even for internal HR tools, you must prevent the generation of hostile or inappropriate workplace content. Any free text input field is a vulnerability that guardrails secure. This decision tree gives you a practical mental model for your architecture planning. You start at the top. Is the AI application user-facing? If the answer is yes, you follow the line straight to mandatory, enable guardrails. There is no debate there. If the application is internal, you move to the next decision node. Does it process open-ended prompts? If your employees can type whatever they want, it is highly recommended to enable them. If it is a strictly controlled, programmatic backend process with no open text, only then do you move to evaluating the risk versus the compute cost of the guardrail processing. Let's dive deep into the actual technical implementation. In Snowflake, this isn't a complex infrastructure setup, it's a simple parameter configuration. When you interact with the AI complete function, whether via SQL, Python, or the REST API, you pass an options object. Inside this, you define the guardrails JSON object. The most critical part is the enablement flag, a simple Boolean set to true. But the feature I want to highlight is the response when unsafe parameter. By default, if the model catches bad content, it returns the literal string, response filtered by Cortex Guard. However, for a polished user experience, you don't want to show raw system errors. You can use this parameter to inject a custom string, like, I apologize, but I cannot assist with that request. This gives you granular control over the application's UX while maintaining ironclad safety. Here we have a simple class diagram illustrating the data structure you will use in your code. You can see the top-level options object for AI Complete, which houses your standard LLM parameters like max tokens and temperature. Notice how it contains the nested guardrails config object. That child object is where you define your enabled Boolean and your response when unsafe string. Visualizing the object hierarchy this way makes it incredibly clear how seamlessly Snowflake has integrated this safety feature into the standard API call structure. As senior engineers and architects, we must always balance security with cost and performance. This deep dive focuses on the billing mechanics of Cortex Guard. Utilizing this safety feature incurs compute charges in addition to the base LLM generation costs. It's vital to understand how it's calculated, token-based billing. The Cortex Guard model charges based on the number of input tokens it processes. But here is the key insight. The input tokens fed into the Guard model are exactly the output completion tokens generated by your primary AI complete call. You are paying the guardrail to read what the main model just wrote. While Snowflake has heavily optimized this for high throughput, running a secondary LLM inherently adds a slight latency to the response. Furthermore, as a coding best practice, consider using the try-complete function, which ensures your application fails gracefully if the safety service encounters a rare execution exception. Let's walk through the economics using this flowchart. Starting on the left, your primary LLM generates its response, producing a set of output tokens. Follow the top path. Those output tokens are billed as your standard base compute cost. Now follow the bottom path. Those exact same output tokens become the input tokens fed into the guardrail model. Processing those tokens generates your guardrail compute cost. Finally, both of these cost streams merge on the far right into your total AI cost. This diagram perfectly illustrates why longer model outputs cost slightly more to validate for safety. Let's solidify this with a highly important real-world use case. Imagine you are the lead architect for a major bank, and you've deployed a public-facing financial support chatbot powered by Snowflake. The threat landscape is real. A malicious user attempts a jailbreak prompt, specifically designing a complex input to trick your bot into generating hate speech or violent threats. Let's say the prompt injection is sophisticated enough that the primary LLM gets confused and actually generates the inappropriate response. Without guardrails, that toxic text goes straight to the user, goes viral on social media, and ruins the bank's reputation. But with Cortex Guard activated, the system intercepts that generated text instantly. Llama Guard 3 classifies it as a severe violation and drops the payload. The user simply receives a polite fallback message like, "I am unable to process that request." Disaster averted, brand reputation protected. This sequence diagram illustrates our cyber defense in action. The attacker initiates the sequence with a malicious jailbreak prompt. The support bot, representing our base LLM, unfortunately processes it and sends the toxic output toward the user. But look at the critical intervention. Cortex Guard steps in. The detects hate speech note highlights the exact moment the safety policy is triggered. The guard explicitly blocks the payload shown by the crossed-out return arrow and forces the system to return the safe, sanitized fallback message to the attacker. It is a perfect depiction of enterprise security working as intended. To summarize, guardrails are not an optional luxury. They are non-negotiable safety nets for any serious enterprise AI application. By leveraging Snowflake's Cortex Guard, powered by the robust Llama Guard 3, you can seamlessly filter out toxic, harmful, and unprofessional content before it ever causes harm. We've seen that implementation is incredibly straightforward, just a simple Boolean flag in your AI complete options, but it provides immense protective value. Always remember to factor in the token-based compute costs for this post-generation evaluation during your architecture planning. Ultimately, guardrails are how you protect your brand, ensure regulatory compliance, and build lasting user trust. Thank you for joining me today. I invite you to like this video, subscribe to our channel, and visit quicktechie.com for premium certification prep. At QuickTechie, you'll find comprehensive Q&A banks, full ebooks, audiobooks, full-length training courses, and exclusive interview guides. See you in the next session. As we wrap up, take a look at this final summary flowchart. Your journey to mastering AI guardrails requires 3 parallel steps: implementing the AI complete function correctly, carefully configuring your guardrails object with custom fallback responses, and vigilantly monitoring your token usage to optimize costs. When you execute these 3 steps in harmony, they all converge on our ultimate goal at the bottom: enterprise safety achieved. Keep this framework in mind as you build your next generation of AI applications.